In this video, we're going to review comparing decimals as well as how to round them accurately. For our vocabulary, let's remind ourselves what the inequality notations mean. So this symbol right here means less than. This one means greater than. And of course, this sign means equal to. Okay, let's think about how we put some decimals in order. So let's start with these four numbers. We have 2, 2.9, 2.85, and 2.105. I want you to go ahead and write down what you think the correct order for them is. Which number do you think is smallest? Did you say it was 2? That's what I think. Let's go ahead and put all these numbers on this number line to help us think about this. So 2 is obviously right here. And then 2.9, that one is also just on our number line here. We can see how all the values between 2 and 3, it's been broken up into 10 parts, one for each tenth. So another way to say this is 2 and 9/10. Okay, now what about 2.85? Well, we can see that it has 8/10. That's like right here. However, it has that 5 afterwards. And what that means is that if we were to take this spot and zoom in on it and break it up into another 10 spots, we would then have 2.81, 2.82, 2.83, and this one right here would be 2.85. So that would be the one that we would want, halfway between 2.8 and 2.9. All right, so I zoomed back out there, but hopefully we can see how 2.89 is right there. Sorry, 2.85, or 2 and 85 hundredths. So now let's look at 2.105. Well, first thing I notice is that it says 2.1. That means 2.1 is right over here. And since there's a 0 in the next spot, I know that it's really close to 2.1. And then it's just a little bit bigger than that because of that 5. So let's see if we can find that spot. So first we go in and we can break it up into tenths, or hundredths, I guess. So 2.1, this is 2.1 here. So this is 2.11, and this would be 2.12. So we want to go in between 2.1 and 2.11. So we're going to go in even further. And then we have to break this guy up into 10. Obviously, my lines are too big to do that. But we can see how right here, we would then be at the 5th one right there. That would be 2.105. Let's go back all the way back. And so now when we zoomed all the way out like that, now we can't even see it anymore. It was so close to 2.1. So it was just right down there was 2.105. So that means that our final order is 2, 2.105, 2.85, and 2.9. And so what we did was we just looked digit by digit. So 2.1 was smaller than 2.8 because 8 is bigger than 1. We didn't even have to look at the later digits. We just had to look at that first digit. All right, now I want you to try. I've written out 2 decimals here. I want you to decide which one is larger. So let's look digit by digit. Well, 2 is the same as 2. 1 is the same as 1. 3 is the same as 3. So far, these are the exact same number. 2 is the same as 2. But now, 8 and 7. 8 is bigger than 7. So that means that this whole number is bigger. And that 3 doesn't even matter. We didn't even need it when we were comparing because that 7 was smaller. If you wanted to, you can always put in an extra 0 at the end to help you visualize it, that this number is sort of like an 80 versus a 73. 80 is bigger than 73. Okay, now let's review how to round decimals. So I just wrote the place values up top, just in case you've forgotten. And let's think about the number 8.56. If I ask you to round it to the nearest tenths place, that means, since tenths is that first digit after the decimal, that I want to have that be my last digit. So I want to have something, decimal, something. So that 8, that isn't going to change because we're only rounding to the tenths place. The real question is what number goes there? Well, since it was 0.56, if we picture that on a number line, this is going to be somewhere between 8.5 and 8.6. And halfway between there would be 8.55. Well, this is at 8.56, which would be slightly on this side. So that means it's closer to 8.6. The other rule for remembering that is that that last digit after the 6 there, since that was above 5, then we round up. Okay, let's try it again. This time, we are going to round this very long decimal all the way to the nearest hundredth. Well, hundredth, that's right there. So let's look at it. We know the 0 will stay. We know there'll still be a 0 in the tenths place. The question is, what goes there? Well, is this number right here closer to 0.01 or 0.00? It's definitely closer to 0.00 because of the next 0 that's after it. So this thing would actually round all the way to just 0.00. Go ahead and try the last 2 on your own before I talk about them. Did you decide that the next one is just 0.7? That's what it should be, because that 3 after the 7 is lower than 5, so it would not round up. The other way of thinking about this is that 0.73 is closer to 0.70 than it is to 0.80, because 73 is closer to 70 than to 80. Finally, if you're asked to round something to the nearest whole, well, that's another way of saying to the nearest 1, or the ones place. So the question is 6.49, is that closer to 6 or is that closer to 7? Well, just like how $6.49 is closer to $6 than it is to $7, this is closer to 6. Okay, now for your practice problem, I would like you to round 3.0771 to the nearest hundredth. Don't be afraid to back up and make sure you know which place value is the hundredth. We will check this in class together tomorrow.